That's the water, the tap we have opened up, and monitoring how water is coming out. And then this is the data acquisition platform, as you can see, fully functional. With the solar panel and everything here, solar panel. And then of course that's the screen over there. So that's the screen, and we're going straight to the screen to see the utilization of water, the temperature of water, how many liters. Like you can see here, we have 610.35 liters, 29 degrees is the temperature of the tank. Then we have the air column, volume percentage at 40.7%. Then we'll have the air column at 92.6. So we could add other parameters here, and then we could actually apply your AI and the ML and do some predictive analysis and so on and so forth. So you can see the temperature changing. Sorry, the temperature is also changing. 27. It was 29 before. The temperature dropped because the air column, the hot air is, I wouldn't know, reduce everything. Absolutely. So I think
greetings from CD4Pi IoT Hub. I'm Ibrahim Sheba, and we are here to present to you the dark remote system, which simply means the data acquisition and remote monitoring system for water projects, agricultural silos, and energy resources like the gasoline, petroleum, etc. Statistics shows that 1 in every 3 Africans doesn't have access to clean and affordable water. And in line with the United Nations and the United Nations Sustainable Development Goal, water is a fundamental human right. Statistics further shows that about 400 million people in sub-Saharan Africa don't have access to clean and affordable water. Nigeria is one of the 46 countries in sub-Saharan Africa that have been plagued with the global water crisis. And of the 780 million people in the world not having clean and affordable water, 40% of these people belong to sub-Saharan Africa. In priority to Nigeria, with places like Sokoto and Katsina, 70 projects in 100 borehole projects have failed due to the unavailability of the system to provide preventive predictive analysis, data reports from this borehole project, and to give accurate data readings of water quality and microclimatic conditions of this environment. CD4Pi presents you with an indigenous technology which is IoT and AI embedded, incorporating these cutting-edge and emerging technologies into this to provide you with an affordable and clean, secure water in most remote rural areas in Africa, Nigeria, and sub-Saharan Africa as well. So it is equipped with environmental sensors like the gas sensor, the humidity sensor, the Dallas thermometer sensor, the ambient pressure sensor, the turbidity sensor, the pH sensor. All of these are a matrix of sensors to give you accurate and precise reading of the quality of water you drink, as well as communication protocols like the GPS, the radio module, the Bluetooth module, and the Wi-Fi module to help with the serial communication in conveying this data via an LTE for remote monitoring of these water projects. Because one of the biggest problems that we have is the unavailability of the companies and the government to look into the projects that have been sunk in several remote regions and also see the performance of these projects.
Okay, before I even explain what is inside, I want us to know that this product, although looking so neat like this, is not an imported product. It is an organic product, fully developed here at TD4Pi Hub. So the board you are seeing here, Unity board, is the main engine, the board that does the magic for us. So it's a robust system, data acquisition system. It's a robust data acquisition system, and without much ado, my colleague will be talking about the functionality of the Unity board as applied to this project.
Here with me is the Unity board, same copy of the board which is in the platform, an indigenous product produced here in Nigeria, which is in line with Pillar 8 and 5 of the National Digital Economy Strategy, which focuses on indigenous content. It is fully equipped with several sensors, which I'll point out to you here on the board, like the gas sensor, which is meant to get your gas readings, the Dallas thermometer, the humidity sensor. We also have the flow rate sensor. We also have the ambient pressure sensor and the luminous intensity sensor. We also have multiple communication protocols like the GSM GPRS module, the ESP module, the Bluetooth module, and the Iridium module. We also have the 7-segment display, which helps out with the counting and the binary sequence for the board. The power section of the board is fully equipped with the solar, which helps out with uninterrupted power supply due to power problems in Africa and most West African countries. And our power specialist will be doing a brief explanation on that.
Yeah, from the solar panel, voltage flows directly into the charge controller. Then from the charge controller, it goes into a 12-volt battery here. So inside the system itself, we have a bulk converter, which gives us 5 volts. We also have 12 volts coming out from the output of the charge controller. And the good thing about this very system is that it is vandal proof. If there's a sensor fixed here, if someone tries to remove the solar panel, it gives us an alarm. The alarm which will be fitted in here.
Okay, this is how the sensor is fitted on the cover of the tank that we use to get the water level of the tank. And this is a sample of the flow rate meter, which I'm going to be showing you where it is fitted. Okay, this is a flow rate meter where it is fitted. Here is the tap. So every water that passes through here gives us the water utilization. This sensor here takes the water utilization of every water that passes through this tap. Okay, as you can see our tank right here, this is the tank we are using, that we are monitoring, and we'll be showing you the data to get data analysis of the tank here. This tank can represent your tank in your water project in a rural area, and it can also serve as a reservoir for a state water board project. And our system here monitors this tank using certain sensors such as the flow rate sensor and the ultrasonic sensor. This way we can get data telling us about the quality of the water and the water usage and the amount of water left in the tank. So here is our ultrasonic sensor. You can see it right here. It's used to tell us the amount of water left in the tank. And we also have the flow rate sensor here. This is a sample of one that's installed already in the tank that tells us the water utilization, with other sensors that also tell us get the microclimate of the area and the quality of water in this tank. Okay, this is how the sensor is fitted on the cover of the tank that we use to get the water level of the tank. And this is a sample of the flow rate meter, which I'm going to be showing you where it is fitted.
No, it's okay. We have more than enough water here, so this is actually the water. That's the water, the tap we have opened up, and monitoring how water is coming out. And then this is the data acquisition platform, as you can see, fully functional. With the solar panel and everything here. Solar panel. And then of course that's the screen over there. So that's the screen, and we're going straight to the screen to see the utilization of water, the temperature of water, how many liters. Like you can see here, we have 610.35 liters, 29 degrees is the temperature of the tank. Then we have the air column, volume percentage at 40.7%. Then we'll have the air column at 92.6. So we could add other parameters here, and then we could actually apply your AI and the ML in doing some predictive analysis and so on and so forth. So you can see the temperature changing. Sorry, yeah, temperature is also changing. 27. It was 29 before. The temperature dropped because the air column, the hot air is, I wouldn't know, reduce everything. Absolutely. So I think
one is this hardware that you are seeing here, and the other one is the web platform or dashboard where the waste manager will monitor different bins installed in different locations. So now the system is solar powered, so which means we don't need external power supply to keep the system running. So as you can see, this is the solar panel with an inbuilt battery that keeps the system running 24 hours without external power supply. As you can see, we have a sensor here that is used to monitor the waste level. So which means the waste managers can monitor the level of waste anywhere they are by just logging into the dashboard. So we have some other features of the system, which includes the ability for the system to know when the device is. So you can also use the device to monitor the orientation of the bin. So which means anytime the bin is not standing or when the bin falls, the waste managers can also dictate. And also, most importantly, you can monitor the location of the bin through GPS. So another aspect of the device is that it will help the people in charge, which is the waste managers. It will help them to craft a very good policy, since we'll be gathering data. The data we are gathering will also be stored on the dashboard, so that anybody or people that are allowed to view the dashboard can use the data for decision making.
yeah, is it getting hot? Or can we switch over to inverter to have more current here? Is it working out? Well, let me see how I want this. But where you, this thing will be on top. This thing should go under here. This thing should go from under here. Under. Put it under so it will go surface. It gives you more liberty that way. Then I can place this on here.
So you have a phone.
Oh, this.
Okay, to inverter. Well, there's serious full current, so you know, checker.
No, they go up. You go up.
Voltage is 200.
So this is a rotonic mechanical smart pump developed here at TD4Pi to solve the problem of inefficiency in evaluation of water projects, especially in the rural areas. This is to account for transparency, accountability, and cost effectiveness of water projects. So the system is so robust with various sensors for data acquisition and metrics of communication modules for data transmission to the back end, where analytics is done, and then information such as the water consumption level, the water quality, and other useful information can be extracted using the supervised machine learning, which is a branch of artificial intelligence. So the purpose of this whole system is to solve the problem of water quality monitoring, water utilization monitoring, and then the efficiency of water projects, especially in the rural areas of Africa. So the use of sensors, which I'll be talking about in a split of a second. This is sorry. This is the pH sensor.
They're not seeing it with you
Okay.
there. Come.
This is
No, I just mentioned that.
Okay, this is the Ruatronic IoT board, fully made in Nigeria, designed here and made here in Kuje, FCT, Nigeria. So we gave it that name because it is indigenous to where it is coming from. So this is the board that will be driving the whole platform. So here we have the GSM module, which we'll be using for our communication. Then another communication channel here is the USB. That's for initial uploading of the program. Then before this, that will be our major communication channel. Okay, here at the back we have the Bluetooth module, but we'll not be using this for this very project. We'll be using the GSM.
According to Statista, the global market for artificial intelligence and the Internet of Things is expected to hit over $1.5 trillion and $2 trillion by 2030. Also, according to a report by the World Economic Forum, Africa will need to create over 25 million jobs by 2025, but only 10 million of those jobs will be filled by people with emerging skills. This skill gap is due to the absence of a project-based learning system for the young population, leading to a barrier for African youth to participate in the global digital economy. Teachers are also pushing to meet this demand through STEAM education, but faces difficulty in gathering resources and components that will help to fast-track learning. Like a certain teacher who teaches STEAM education with Arduino, but finds it difficult to get other components and resources which complete these learning tools because of cost and availability of these components. That is where our solution comes in. The Unity Board, a unified IoT project-based learning system. The Unity Board is an AI and IoT STEAM education kit that provides students with an immersive hands-on educational experience that is both engaging and informative. It introduces them to the world of embedded artificial intelligence and Internet of Things, preparing them for the future. Our kit includes the Unity Board, which is Arduino compatible, a very powerful microcontroller board that supports artificial intelligence and Internet of Things applications. Also included is a variety of sensors, including the temperature sensor, motion sensors, and so on. Also the actuators, which include LEDs, buzzer, and solid state relay. We also have a very user-friendly interface for programming, which is very perfect for beginners. Our kit provides many benefits for both students and teachers, which include hands-on experience, where students get to build projects on their own. Also, real-world application, where students learn how to apply these projects on AI and IoT on real-world problems. Our kit is also very easy to use, which is very perfect for beginners, and we also have a very comprehensive curriculum for teachers to help them in planning their lessons and activities. And more also, our kit is very affordable for schools who have limited resources. Our kits have unique features which cannot be found in similar products in the market like the Raspberry Pi and the Arduino Uno. These features include multiple sensors on board, multiple communication modules like the Wi-Fi, the GSM module, and the Bluetooth connector. Also, a real-time clock on board the device. Currently, the Unity board has been adopted by the Nigerian government for imaging skills training.
It is actually an education technology platform championed by the Honorable Minister of Communications and Digital Economy, Professor Isa Ali Ibrahim. And it started right from when he was Director General of National Information Technology Development Agency. So it is a platform for acquisition of skills. Just as the Minister always says, it's no longer just certificates, skills comes in and competence. That is what is driving the fourth industrial revolution. So this is a board model for acquisition of skills in artificial intelligence, Internet of Things. Recall, Internet of Things is one of the pillars of the fourth industrial revolution. And this is designed in line with our uniqueness and peculiarities in Nigeria, particularly in Africa in general. So this is an example of indigenization of technology, which is part of the NDEPS document, also championed by the minister as well. So it's proudly made in Nigeria, as you can see the flag, branded, everything. These are meant for schools, as early as 6 years, primary school up to secondary school, universities. And this is a practical way of acquiring fourth industrial technology skills for field application that will catalyze startups and then give us what we call a digital sovereignty. I think I'll stop here and let the Honorable Minister, who is the champion, present this to him as well. Sir, this is a job a champion. This was his idea. Yes, so he is what we call a local content ambassador right from day one. And thank you, sir.
Yeah, as he said, we have been working on this for almost 5 years.
5 years, yes.
We even took this to the Gulf Information Technology Exhibition, where we demonstrated it. And at that time, we commenced the process of obtaining its patent and many more. We are grateful to where we are today. Where is the battery?
So, Honorable Minister, we demonstrate the AI components of it. Okay. So basically, what the HM is actually doing now is showing the AI part of it. Artificial intelligence is basically mimicking of human intelligence. So this very device sees the direction of his hand waving, and the light changes, and so on and so forth. So it can be applied in several solutions, absolutely.
We are very proud of it for the technology, and it's just an encouragement and a challenge also to our younger ones and our children to develop their skills and also be very successful. More details could be released later.
Yes, sir. Okay, thank you, sir. Well, congratulations.
Thank you very much, Dr. Abu Collins Agu. Thank you.
Who technically assisted while I was in office there. Credit is for teamwork, auto, co-auto, and also the coordinator on my behalf.